Hello everyone, we're going to solve the initial value problem y double dash plus 3y dash plus 2y equals e to the negative x, where y naught equals naught and y dash of naught equals naught. Alrighty, so the steps to solve this equation is first, step 1 is to find the general solution to the homogeneous equation. If you don't know what this means, it doesn't matter. It's just a series of steps to do this. So first we set this equal to 0. So let y double dash plus 3y dash plus 2y equal to 0. And now let these be the lambdas. So lambda, there's two dashes, so it'll be a squared, plus 3, the constant, lambda, because it's just 1, plus 2, since there's no derivative, it's just a 1 there. So this equals 0. So now we have to solve for this equation. We need to find what lambda would be. So we need to factorize this. So what two numbers times to equal this and plus to equal this is 2 times 1 and 2 plus 1. So 2 times 1 equals 2, 2 plus 1 equals 3. So our numbers are 2 and 1. That's what we want. So it's lambda plus 2, lambda plus 1 equals 0. And now split each of these to equal 0. So lambda plus 2 equals 0, lambda plus 1 equals 0, lambda equals negative 2, lambda equals negative 1. So what do we want to do with those now? So the YC, which is the general solution to the homogeneous equation, so this is what we're finding in part 1, this is our answer, equals C1, a constant, times e to the lambda negative x, so it's e to the lambda x plus C2 e to the other lambda x, so it's negative 2x. So that's our general solution to the homogeneous equation, and we will keep that aside. So now what we did was we ignored this right hand side of the equation to find this, didn't we? We set it equal to 0, so practically we're ignoring it. So now we need to find the particular solution, and we now use this side. So part 2, find the particular solution. Okay, so y of p, that's particular solution, equals, so up here we've got e to the negative x, right? But if we look down here, in our general solution to the homogeneous, e to the negative x is already a part of it. So we actually need to manipulate this. So we have a constant, and we have e to the negative x, which is this side, but since this was already found in the homogeneous part, we need to times this by an x. So it's just a little trick you do. So this is because, yep, e to the negative x is a solution to the homogeneous problem. Alrighty, so let's take the derivative of this. Yp dash is, we use the chain rule, I think it is. So first it'll be, grab the first part. So we can just pull the a out the front. Let's ignore, just put that out the front. So we've got e to the negative x times x. So first we differentiate e to the negative x, which is negative e to the negative x, and we leave x as it is. and then we add the derivative of x, which is 1, times, leave this as it is. So the method of that is take the derivative of this, leave that, plus take the derivative of that, leave that. So that's what we've got just here. Yep. And now we can take the derivative again. So the derivative of this is, first we can leave the a out the front, just as normal, and let's differentiate this first. So grab this, take the derivative of this, is negative e to the negative x, so it's positive e to the negative x, and leave x as it is, plus take the derivative of x, 1 times, oh, sorry, this will be a minus because this guy, minus take the derivative of that plus that, times that is e to the negative x, and take the derivative of this is negative e to the negative x. So negative e to the negative x minus e to the negative x is 2 e to the negative x, so yp double dash is a e to the negative x, x minus 2 e to the negative x. So all I've done is combined these two sections. Okay. So now what do we do with this? So the purpose of doing this was to then substitute into our original formula. Okay. So this will get, so our original formula is important to remember, so y double dash plus 3y dash plus 2y equals e to the negative x. That's our original formula. And y double dash was this. So it was ax e to the negative x minus 2a e to the negative x. So all I've done is pulled in the a now. So before a was just out the front, so now times it in. So this will be a e to the negative x, x minus 2a e to the negative x. And we can do the same for yp dash and, yp doesn't need to be expanded in. So now we need to put y dash in. So it's plus 3, and y dash was negative ax e to the negative x plus a e to the negative x. And now the y bit, so it's plus 2, that's that constant there out the front. Now let's substitute y in, and y was just ax e to the negative x. And don't forget the right hand side of the equation equals e to the negative x. So that was a lot of substituting into the equation, so hopefully you followed that. So all we did was substitute this part, and this part into our original equation. So now we need to simplify this. So let's expand in the 3's and the 2's. So we've got ax e to the negative x minus 2a e to the negative x, so that's just that bit, nothing's happened to it, plus 3, so if we times this in, it'll be negative 3a, so it'll be negative 3a x e to the negative x, that's a negative, and it'll also be plus 3a e to the negative x, so I just times that in like that, and it'll be plus 2ax e to the negative x equals e to the negative x. Alrighty, so simplifying this down, what have we got? I should get a highlighter. Okay, so we've got an x bit, another x bit, so it's x e to the negative x, x e to the negative x. See this bit, it doesn't have an x, so we're not highlighting that bit, and this section. So now we look, we've got let's pull it out the front. X e to the negative x. What's left over? We've got an a, we've got a minus 3a, and we've got a plus 2a. Okay, and what else do we have? For the non-x section, we've got this, and we've got this. So it'll be plus e to the negative x. So I've just pulled out an e to the negative x here, and it'll be minus 2a plus 3a equals e to the negative x. Okay, now let's simplify this. A plus 2a is 3a, minus 3a is 0, so this part's just 0. That part's just 0. Plus, what's this? 3a minus 2a is just a, so it's plus a e to the negative x. So, equals e to the negative x. So what does this show? All it shows is a e to the negative x equals e to the negative x. So what does a have to be? Sub in 0, that won't work. Sub in 1, that works. So this means a equals 1. So where do we go from here? This is a very long process. We go back to our y of p. What was our equation? A e to the negative x, x. And since a is 1, it's good to write since a is 1, y of p equals e to the negative x, x. A is 1, yp equals e to the negative x, x. Okay, so therefore we can now combine this guy and we can combine this guy. So we know y equals yc plus yp. And we found y of p is e to the negative x, x. And y of c is c1 e to the negative x, c2 e to the negative 2x. So y equals c1 e to the negative x plus c2 e to the negative 2x plus e to the negative x, x. Now, we're not done, are we? The one thing we haven't used, given in the question, was this. We haven't used our initial conditions. So, our initial conditions are used to find C1 and C2. So, a trick to do is see that we've got a derivative of y. Here we only have y, so we know we need to find the derivative in order to find C1 and C2, and we'll get two simultaneous equations. So taking the derivative, y dash equals negative C1 e to the negative x, so I just took the derivative of this, plus, it'll be a minus because there's a minus here, minus 2 c2 e to the negative 2x. And now this is chain rule again. So take the derivative of this, negative e to the negative x, and leave this as it is. X plus take the derivative of this, 1 times leave this as it is, e to the negative x. So we know when up here, when x equals 0, y equals 0. When x equals 0, y dash equals 0. So that's what that means, and that's what that means. This is x in here. Okay. So, first we can substitute into the first equation. So, 0 equals c1 e to the 0 plus c2 e to the 0 plus 0, because that would just be 0, all of this. And now let's sub into the second one. So that was that one. Now let's sub into the second one. 0 equals negative c1 e to the 0 minus 2c2 e to the 0. This will be 0, and what will this be? Plus e to the 0. So e to the 0 is 1. So what does this equal? What does this first equation equal? c1 plus c2, so that implies c1 plus c2 equals 0. So all I've done is just equated and calculated e to the 0. So, and the second equation means 0 equals, e to the 0 is 1, so negative c1 minus 2c2 plus 1. Okay, fantastic. What else? What do we need to do now? What we need to do is now solve these equations simultaneously. So we'll need to write them down. So this is equation 1, this one. This is equation 2. Yep. So I'll write them again here. So c1 plus c2 equals 0. And 0 equals negative c1 minus 2c2 plus 1. Okay, first we look at this one. c1 equals negative c2. So I've moved this guy over, and it's turned into a negative, so c1 equals negative c2. Now we can substitute that into this one. So 0 equals negative c2. So now I'm just substituting c2 whenever there's a c1, or you can do it the other way, substitute a c1 whenever there's a c2, it doesn't matter. So this is now negative c2 minus 2c2 plus 1. So 0 equals, this is just c2 minus 2c2 plus 1. So let's move this 1 over. Negative 1 equals negative 1c2. So negative, negative, positive, so this means c2 equals 1. Okay, and since we can now look at this equation, what did this tell us? What did this equation tell us? Since c1 equals negative c2, c1 equals negative 1. So c1 is the negative of this number. So it's just negative 1. So what does that tell us? Back here, our y of c is c1 e to the negative x plus c2 e to the negative 2x. So y of c is actually in fact c1 negative e to the negative x. Do we see that? Plus c2 e to the negative 2x. So finally, after applying initial conditions, y equals. So remember, this is our y equation. This one here. Y equals c1. Y of c plus y of p. Right. Best to write this again, so there's no confusion. So y of c is now negative e to the negative x plus e to the negative 2x. 2x. And y of p, as we remember, was e to the negative x. So it's plus e to the negative x. Fantastic. So that's how we solve the following IVP. So the steps are to first find the general solution of the homogeneous equation. I'm just going to run through what we've all just done again. So we take the left-hand side equals to 0, set the lambdas, solve for lambda. So then we find the general solution of the homogeneous equation. where it's some constant times lambda 1x. So this could be lambda 1 and lambda 2, or lambda 2 and lambda, doesn't matter. So it's c1 e to the lambda x plus c2 e to the other lambda x. Okay, so now before finding these constants we need to find the particular solution. So what we do is we take the general solution to this side of the equation. So in this case, e to the negative x was already found in our homogeneous equation, so we had to manipulate it by putting an x out front. In other situations, if this was a polynomial, you would write the equivalent polynomial. You can find a table of them on Google Images of what general particular solutions you should actually use in different situations. So then we took the derivative of this, and we got three equations. We got y, the particular solution of y, the derivative, and the double derivative. And then we need to go back to our original equation and substitute these in, as was done here. I know it's a bit messy, but this is all the substitution. We equate the coefficients. So that means we take all the coefficients out front, x e to the negative x in this case, and all the constants out front, e to the negative x, and we simplify it down into this simpler equation. We find the constant a. In different situations you might need to do multiple simultaneous, like simultaneously find a, b and c using different simultaneous equations. In this case we were very lucky and it was a very easy equation to find a, but in some cases you might actually need to do simultaneous equations. Okay, so then we found a and we substituted that back into our particular solution of y of p. And we know that overall the solution is actually the homogeneous plus the non-homogeneous part. So when we're talking about the non-homogeneous part, that's this bit, and the homogeneous is this bit. So this is homogeneous, this is that's non-homogeneous, that's homogeneous. Righty, so we did that, but we haven't found the constant c1 and c2. So we know using the initial conditions, we then did that, take the derivative, substituted our initial conditions. So say this was actually 2, so here we go, so say this was 2, instead of subbing 0 as the x value, we would do c e to the negative 2 minus 2 c2 e to the negative 2 times 2, etc. So instead of subbing 0 we would actually sub 2, and then we'd have to do simultaneous equations with that. So 0 is actually a blessing in this case, so e to the 0 is 1, which is making it really nice. E to the 2 is actually in fact really annoying and more difficult to work with than if it was 0. So after all that, we've found the constants, we've found the non-homogeneous, we've found the homogeneous, and we get our final solution of y. Okay, so that's how to solve one of those. Thank you for watching. Subscribe. Leave a comment if you want me to do any other questions or you get stuck on anything I just explained. Okay, see ya.